Hi, how's it going? Welcome to Code with Z. In today's video, we're given this array called nums, and we gotta go from this array to these subsets here. Why are we doing this? Well, because that's what LeetCode 90 subsets part 2 is asking us to do. As you can see, it says, given an integer array called nums that may contain duplicates, as you can see, nums, and it has duplicates, return all possible subsets, and the solution must not contain duplicate subsets. So for example, here we don't have duplicate subsets. You don't see two of this array. We only have one set of 1, 2. We don't have two sets of 1, 2 and another 1, 2. So let's see how you can solve this. Let me first bring this here. In this type of problems, when we're looking to find all of the possible answers, we usually use backtracking. And as you saw, when we returned our result, our subsets were inside of an array. So we need to have a result array. And I'll visualize the whole process so you see how everything works with your own eyes, so you never forget it. But just like you saw, all of our answers and all of the subsets that we're going to return have to be inside of an array, and this is going to be that array. And when we start with an empty array. We don't have any subsets yet, and we don't know what subsets we're going to have. But when we start with an empty array, this can itself be a subset. We can have an empty subset. So we're going to add this to our result because this is also a valid answer. And then we're going to be like, okay, because we're going to be using backtracking, we're trying to explore all of the possible solutions. We're going to be like, okay, we have an empty array and we're trying to find subsets. What will happen if we add 1 to our subset? This is a valid subset and it's not a duplicate. We don't have 1 yet. So this is also a valid subset and we're going to be like, okay, because this is a valid subset, let's add it to our result. Simple as that. And then we're going to be like, since we've added 1, that means we've explored this part of the array. So the only remaining options are going to be these two numbers that we have here, like so. And then we're going to be like, okay, we've explored this part. What will happen if we add this number here? What will happen if we add 2? Well, this is also a valid subset. So we're going to be like, okay, let's add this to our result as well. Now we have 3 subsets that we have discovered throughout our backtracking. And then we're going to be like, okay, now we have discovered this part of our array and this part is remaining. What will happen if we also explore this part and add 2 to our current subset? Well, if we add 2, this is going to be also a valid answer. So we're just going to add it to our result. Simple as that. And then we want to keep on exploring, but there's nothing more to explore. We've already explored everything that we have here. So we're going to be like, okay, we discovered where we end up if we start with 1. Let's see where we end up if we actually start with 2. Because if we think about it, we just took 1 and went on with it. But what will happen if we don't start with 1 and we start with 2? Because this is also a valid answer. We can start with this one instead of this one. And if we check, this is also a valid answer. So we can just add it to our result. It's not a duplicate. We don't have any 2s here. As you can see, we don't have a single 2 inside of an array. It's only this one. When we are here, we say that we started with this number and we're not going to explore the previous ones because we know our code has already discovered those. As you can see, our code has already started with 1. So when we start with 2, we're not going to check the numbers that come before it. We're going to check only the numbers that come after it. So we're going to be like, okay, let's see what will happen if we add 2 because this is also a number that has not been explored and it's after the number we started from. This is really important. This is after the number we started from. We started from this number and this 2 here is after that. So we're going to add it here and we're going to check and see if this is also a valid answer. We don't have any 2 and 2s here. So we're just going to add it to our result. Simple as that. And then we want to explore further, but there's nothing to explore. As you can see, we've already explored everything that came after our starting point. Then we're going to be like, okay, let's see what will happen if we start with this second 2. Because we checked what will happen if we start with 1, which is this number here. We checked what will happen if we start with 2, which is this number here. As you can see, this one. But now we have to check what will happen if we start with this 2. Well, before we do that, we're going to check if we've already started with a number that's similar to this current number. Well, yeah, the previous number is also 2, and we've already explored the possibility of starting with 2. So if we try to explore the possibility of starting with 2 again, we're going to get duplicates, so we're just going to ignore it. And then there's nothing more to explore and start with, so that means we're done, and this is going to be basically our answer, and we're just going to return this. Simple as that. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to have is gonna be our result variable, just like we saw on the slides. So this is gonna be initialized to an empty array. And then we have to have our backtracking function that we're just gonna keep on calling to explore all of the possible answers. And this is gonna be pretty simple. We're just gonna name it backtrack. And this is gonna have two variables. The first one is gonna look really familiar, and it's gonna be called current array. And this current array is basically the array that we had in the slides. If you remember, we started with an empty array, and then we were like, let's add, for example, 1 to this array. And then we were like, now that we have 1 inside of our array, let's add, I don't know, for example, 2 to that array, like so. Basically, the array that we just kept on adding numbers to is gonna be this current array. And then we also have another variable, and that variable is gonna be called start, like so. Let me put a space here. Start is going to be basically telling us where we start from. For example, if you remember, if this is the array that we are given here and we need to explore all of the subsets for this array, when we started with 1, we explored all of the possible answers. And then when we started with 2, we didn't go back to check what we had with 1. We were like, we're just going to check all of the numbers that come after the number that we started from. And this start is going to be basically representing that. If you remember in the slides, on each step, we just added the current array that we had to our result. So we're going to do the same thing here. We're going to say result.push of current array, like so. And then once we did that, we were like, okay, let's explore all of the possible answers from this point. For example, if we had 1, we were like, okay, let's see what will happen if we add, for example, 2 to it. So because we need to start from this and call our function to explore all of the possible answers after this, we have to have a loop. We're just gonna say for let I being equal to start. Don't worry, I'm gonna explain this. And we want to keep on looping as long as I is smaller than nums.length and I++ on each round. Inside of this for loop, we have to explore possibilities. Let's keep on with our example. For example, we have 1 inside of our current array, and we want to see what will happen if we add 2 to it. So to do this, we're gonna be like, let's first add the 2 to our current array, and then we have to call our backtracking function once when our current array looks like this. So you have to go from this situation that we have here to this. And to do that, we're just gonna say current array dot push of nums with the index of I. This is basically going from this to this that we have here. We just added it to our current array. Now that we have added this to our current array, we want to call our function again. So we explore possibilities once we start with this. So we're just going to say backtrack, like so, and we're going to call it with I+1 because we want to increment where we start from. We don't want to start from the same position. And we're going to pass it the new updated current array. We say I+1, and this is representing our start because we don't want to start from 1 again. We want to start from 2. So we incremented where we start from because it's going to be the next round, and we pushed our updated current array. Simple as that. Now let me delete this. And then once we call this, this is going to take care of the possibility that we have here. It's going to explore the solutions with the updated current array. And for the next round of this loop, because we are inside of a loop, we want to start fresh again. We want to start, for example, we say we start with 1, but we also want to see what will happen if we start with 2, just like we saw in the slides. So because we also want to start fresh, we're going to say, after we've called this function, we want to clean up our current array so we explore other possibilities in the next round. So we're going to say current array.pop. Simple as that. What this is doing is that it's going to first push a new number inside of our current array, and that new number is going to be at the I index. So after we've pushed the number with the index of I inside of our current array, we're going to call our backtracking function to explore that possibility. And then we're going to be like, now let's pop this out. And when the next round I gets incremented in the loop, we want to explore another scenario. We want to explore what will happen if we add that new number that has the next index. So we're going to push that inside of our current array. We're going to call our backtracking function with that, and then we're going to pop it. And then we're going to be like, okay, let's see what will happen if we add the next number, because I just keeps on incrementing on each round. So we're going to add a new number to our current array, and then we're going to explore that. And we're just going to keep on doing it to explore all of our possible answers. Now, let me delete this. This is going to be our function, but we also have to avoid duplicates. As you can see, it says we must not have duplicates. So we're just going to say if I is greater than start, And don't worry, I'm going to explain this. Nums at the index of I is equal to nums at the index of I minus 1. Basically, if we have a duplicate, for example, 2 occurrences of the number 2, we're just gonna skip because we say continue. And this is like saying skip this round. And that's gonna avoid having, for example, 2 similar sets in our output. That's why we have this line here. This is gonna be basically our backtracking function. The only simple thing that's left is gonna be once we push this inside of our result, we have to push a copy of it, not itself. So we're just gonna say spread current array. And this is basically like saying we copy what we have here and we just push it here. Basically the same thing, but instead of pushing the array itself, we have to push a copy of it. And this is gonna be our backtracking function. And here we have to call it. So we're gonna call it with 0 because we have to start from the first number and the first number has the index of 0. And we also start with an empty array just like you saw in the slides. In the slides, the first thing that we added to our result was an empty array. And speaking of result, now that we've called our backtracking function, our result array is filled with answers. So we have to return our result like so. Now the only thing that's remaining is that because we have to check for duplicates, we have to make sure that the numbers that are equal to each other are next to each other. So when we say if the current number is equal to the previous number, continue or skip, those numbers have to be next to each other. So to do that, we have to sort our numbers. So we're gonna say nums is equal to nums.sort A and B. And this is basically how we sort an array of numbers in JavaScript like so. And this is gonna be everything that we need. Now let's run this. I hope I've not made any typos. Let's see if we can actually get accepted. And yep. Now let's submit this and see if we can actually pass all of the test cases. And yep, that's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.